Now, in this lecture, we are going to prove that magnet performs angular S.H.M in uniform magnetic field. I am going to obtain expression for time period of magnet. Consider a uniform magnetic field of magnetic induction B. If a bar magnet is freely suspended in this uniform magnetic field, so it will remain in equilibrium with its axis parallel to the direction of the magnetic field, like this. When its axis is along the direction of magnetic field, this is equilibrium or mean position of this bar magnet. Let mu be the magnetic dipole moment of this bar magnet, and its value is equal to 2L into Qm, where 2L is magnetic length and Qm is magnetic pole strength. Now this bar magnet is given a small angular displacement theta and it is displaced about its axis and released. तो वो क्या करेगा? It will perform, that magnet performs angular oscillations, मतलब वो oscillatory motion करेगा. तो theta angular displacement of magnet. In this displaced position of the magnet, two forces are acting on that magnet. One is acting along the direction of magnetic induction and second one is acting opposite to the direction of magnetic induction. These two equal forces opposite in direction form couple and its value is given by torque. So we can write here formula for torque acting on this bar magnet. Therefore, torque is equal to magnitude of one force into perpendicular distance between two forces. And force acting, any one force acting on the bar magnet is given by F is equal to QMB. ये फॉर्मूला हम लोग को मिलता है बाय डेफिनेशन ऑफ मैग्नेटिक इंडक्शन से, कि मैग्नेटिक इंडक्शन इज इक्वल टू फोर्स पर यूनिट पोल स्ट्रेंथ. पोल स्ट्रेंथ हियर इज डिनोटेड बाय QM एंड मैग्नेटिक इंडक्शन इज डिनोटेड बाय B. सो फोर्स, दोनों जगह पर फोर्स का मैग्नीट्यूड सेम रहेगा बट डायरेक्शन अपोजिट रहेगा. सो वी कैन यूज दैट फोर्स हियर. परपेंडिकुलर डिस्टेंस बिटवीन टू फोर्सेस इज SP. दिस डिस्टेंस, दिस इज डायरेक्शन ऑफ फर्स्ट फोर्स, दिस इज डायरेक्शन ऑफ सेकेंड फोर्स. तो SP का वैल्यू अभी हम लोग निकालेंगे. सो हियर इन दिस राइट एंगल ट्राइंगल NPS sin theta is equal to opposite side upon hypo, that is SP upon SN. SN is nothing but the distance between south pole and north pole and it is nothing but magnetic length 2L. So we get SP is equal to 2L into sin theta. Therefore torque is equal to QMB into 2L sin theta from equation 1 and 2. But we know that कि 2L into QM is nothing but the magnetic dipole moment of bar magnet. So substituting here we get torque acting on bar magnet is equal to, but theta is very small angular displacement, therefore sin theta is approximately equal to theta. Now this value of torque is in magnitude, but we know that कि restoring torque acts in opposite direction to that of angular displacement. So here we will take negative sign. Let this be equation 3. In previous lecture we have seen that torque is also given by I alpha. Let this be equation 4. Now equate equation 3 and 4 and we get I alpha is equal to minus mu b theta. Therefore alpha is equal to minus mu b theta upon I. But here mu b upon I, this value is constant for given bar magnet. So we can write alpha is directly proportional to minus theta. Last part I am writing here. In angular S.H.M, we know that angular acceleration is directly proportional to minus theta, that is to angular displacement. So we can say that magnet is performing angular S.H.M in uniform magnetic field. Now let us obtain time period of a bar magnet in uniform magnetic field. तो उसके लिए यू हैव टू राइट ऑल दिस एक्सप्रेशन और इसके आगे के स्टेप्स भी हम लोग करेंगे. टाइम पीरियड मीन्स टाइम टेकन बाय बार मैग्नेट टू कंप्लीट वन ऑसिलेशन. तो ये बार मैग्नेट की मीन पोजीशन है. जब वो यहाँ जाएगा वापस यहाँ आएगा, इट विल गो टू द अदर एक्सट्रीम पोजीशन एंड विल कम बैक. तो उसका एक ऑसिलेशन हो जाएगा एंड फॉर दैट वॉट एवर टाइम इज रिक्वायर्ड इट इज कॉल्ड इट्स टाइम पीरियड. And we know that time period is given by t is equal to 2 pi by omega. And we also know that omega is square root of angular acceleration per unit angular displacement. In previous lecture we have seen that. So we can write that formula directly. From equation 5, alpha is equal to minus mu b theta upon I. So theta is shifted on this side. So we can write magnitude of alpha theta is equal to mu b upon r. Alpha is angular acceleration, theta is angular displacement. So we get angular acceleration per unit angular displacement, that is alpha upon theta is equal to mu b upon r. So substitute this value here and we get t is equal to 2 pi under root I upon mu b, where I is moment of inertia of bar magnet, mu is magnetic dipole moment and b is magnetic induction of magnetic field. And this is the expression for time period of a bar magnet in a uniform magnetic field. Now by this we can calculate frequency of bar magnet also, and frequency is reciprocal of time period. So we can write frequency n is equal to, therefore frequency n is equal to 1 upon 2 pi under root mu b upon r.